Now, how to representation of a galvanic cell. Here for the representation of a galvanic cell, we have standard IUPAC notation. That IUPAC nomenclature for organic compounds, as we learned, there is a systematic procedure given by Indian Union of Pure and Applied Chemistry, International Union of Pure and Applied Chemistry. Here also we have a systematic notation for galvanic cells to represent. According to the IUPAC convention, International Union for Pure and Applied Chemistry, which is just an association of all senior chemists around across the globe, which suggest all modalities to be followed in the chemistry education. So, according to that IUPAC convention, the cell representation is that the anodic reaction followed by salt bridge and cathodic reaction. So, here in a zinc copper couple, if you have two metals, if two metal half cells are used, if two metal half cells are used, in which metal 1 is oxidation, suppose if metal 1 undergoes oxidation to solid metal, undergoes oxidation to metal ion, and metal 2 undergoes suppose reduction by the same Na electrons, then the representation is that solid metal 1 oxidized to metal ion aqueous. When you are writing it like this, metal, the reduced form and oxidized form. On the left side what you have here is reduced form, on the right side what you have is oxidized form. If you are writing like this, this indicates oxidation. But if you write metal ion first, then the solid metal next, then that represents reduction. Here metal 1 is undergoing oxidation. So, I wrote oxidation first. So, basically the point is the metal and metal ion are separated by one vertical line. Metal ion separated by a vertical line, whose meaning is that a solid metal is oxidized to aqueous metal ion in the galvanic cell. So, as I told already, if you write metal oblique metal ion, it represents oxidation. But if you write metal ion first, then metal next, that represents reduction. Now, here metal 1 is undergoing oxidation. So, first I am writing the oxidation, and remember that according to IUPAC, the oxidation should always be written first, that is on the left hand side. And here in case of a metal ion also what we should represent is the concentration of the metal ion, like in the case zinc sulphate. What is the concentration of zinc sulphate solution? That concentration we should mention over here, and this is, then we have to draw two parallel vertical lines. The two parallel vertical lines represent salt bridge. Then next, so this is basically anode or oxidation half cell. So, this is oxidation half cell or anodic half cell. Then on the right hand side what you should write is a reduction half cell. Now, the reduction is for the metal ion 2 and that here as it being the reduction. So, ion should be written first with its concentration in the brackets, separated by again a vertical line to the solid metal. So, here metal ion is getting reduced to metal, here metal is oxidized to metal ion, metal oxidized to metal ion is getting reduced to metal. So, this is oxidation and this is reduction, oxidation half cell, reduction half cell, both are separated by a salt bridge. This is what we have seen in the construction, right. So, whenever you are having the cell reactions like this, then this is the cell representation, and here both the cases what we are taking is in both oxidation half cell and reduction half cell, what we are taking is only the metal metal ion combination. But here also what we can take is the non-metal electrode also into consideration. So, when you take this metal metal ion, this is a cell notation just where we have to represent the concentrations of the solutions in the brackets. Now, if it is a non-metal, then how do we take a non-metal and what is the construction of the non-metal? In the case of metal, simply you can dip a metal rod or a metal wire. A metal wire, if you just dip in a metal ion solution, that will give you an electrode, that forms electrode, and that is a half cell. But in the case of a non-metal, for example, if you have a hydrogen, oxygen or any other non-metal, chlorine, like these gases if you have, then how do we get an electrode using these gases? Yes, using gases also we can have an electrode. Then how to construct that non-metal electrode, how to represent that non-metal electrode, and how do we put it in the combination of metal electrode. A metal non-metal combination or two non-metal combinations, how to get it, how to draw it, how to construct it, that now we see.